Hey everybody, welcome to the Seneca OOP 244 Workshop 2 Lab walkthrough for the Fall 2024 class. Let's get right into it. So this workshop is going to be going over references, overloading, dynamic memory allocation, and compound types. So let's scroll down to where the lab is, and let's read what we need to do. We have step 1, and we have step 2, and then step 3. So let's focus on step 1 for now, and let's get this all tested. So we'll be working in the module called input, and inside of this module there's a function called getInt, and it's fully implemented and it works. So the whole point of this is to get a foolproof integer entry from the console. So it reads and returns an integer from the console. And it'll catch any errors that may come up. So our task is to overload the getInt function by introducing a minimum and maximum parameter. So when we enter in data, we could get data between a specific range that we want. So let's go ahead and get started. Let's create a new project and import all of these module files here. So let's do create new project, empty project. Next, we're going to call it Workshop 2 Lab Fall 2024. Let's press create. Okay, so our project is created. So let's go ahead and click source, right click add. We're going to add a class. We'll call it input. Press OK. And then just delete everything that's inside of the .h file here. Let's now create another class. Let's create the DMA class as well. Okay. We're going to delete this. And lastly, let's just create that main file as well. So we'll do right click, add a new item, and we're going to add main.cpp. So by creating new classes, you just get the file structure here. It's just easier to do it that way. So it creates the both H and CPP file. So let's go into each one of these files and copy in the contents from the lab. So let's start with main. So let's click main. Let's click this copy button, and then we'll do Control V to paste it in. Perfect. Now let's do the input.cpp file here. So let's go back to lab. Let's go to input.cpp. Click copy. Let's do Control A, Control V. Okay. Now let's do the dma.cpp. So let's go back to the lab here. DMA, copy, and then let's paste it in here. Now back to the input.h. Input.h, we're going to copy it, paste, and then DMA. So we're going to go into DMA.h, copy it, and paste it in here. Okay, so everything's copied in. Let's go back to the lab now. So let's start with the overloaded getInt function to accept a minimum and maximum parameter for getting an int. So let's go to input.h, and underneath this comment, let's create the new function data type. So we're going to return an int, call it the same name as above, so getInt. So we'll take in a min value and a max value, and they'll both be ints. So we'll do int min value, and then int max value, and then semicolon. So let's go ahead and create this function inside of the source file. So let's create the definition. Okay, let's clean this up. Okay, so what we need to do is we need to get an input from the user. So get an input from the user, and then we need to check if it is in the range. So we got to check if it's in the range. Then we need to repeat if it's not. And then lastly, we will return the value. First, let's just write out the simple logic to get the value from the user. So we are going to make something called user value. So we'll do int user val, and we'll make this equal to get int. So this is our foolproof way of getting an integer. Next, let's just check if this is in the range. So we'll say if user value is greater than or equal to the minimum value, and if user value is less than or equal to the max value. So if this condition is true, we will return user value. And if it's not true, that means our integer would be out of range. So here we will write the error message. So let's write cout, and we'll write invalid value. So we want to basically just copy this here, and then we'll do a comma. We're going to put an open square bracket here, and then the arrows, and then we're going to put our min value here. And then we're going to basically write this. And then let's put our maximum value here. And then let's put the closing square bracket. We're going to put a new line and then end it with a semicolon. Okay, so I think that should work fine. And then down here, let's also just write return user value. So at the moment, this should work, but it'll only work if we want to try to get the user's input once. Now we need to throw this into a loop. So let's clean up the code a little bit. Let's delete these comments now. So we just need to do the repeat if it's not valid. And the way how we're going to do that is use a do while loop. So let's write do and then close it down here and write while. So now let's write a Boolean to check if the user entered in a valid input. So we'll write Boolean is valid equals false to start off. And we're going to want to keep running this loop while we do not have a valid input. So we're going to say exclamation mark. So this is saying not, while it's not valid. So we can write if it's not is valid, then keep running, because once it's valid, we'll update this to true. So the next modification we need to do is we need to now call this logic inside the loop. So if the user enters in a bad value, it'll say invalid, and then it'll prompt them to enter in another number. So we're just going to copy this, and we're going to paste it inside of here. And then let's just create the variable up here without assigning it any value. So as soon as the loop runs, we will create our variable, create our user value, and then once the loop starts running, we'll get an input from the user. We'll check if it's within the range. If it's within the range, we will update is valid to true. And if they don't enter in a valid input, we'll just print out our error message. So once we hit this line, we'll know whether or not to run the loop again. And then once we exit the loop, it means we have a valid input from the user, and then we just return it back to whoever called it down here. Let's go over to our main function, and let's just quickly test this to make sure that it works as expected. So this is our main function here. Right now we don't have anything else implemented, so I'm just going to kind of indent this a little bit, and I'm going to put a big comment here just to comment this all out so we don't get an error for now. So the only thing I want to do right now is call test get ints. And then I also want to comment out this whole method here. So if you highlight it and press Control and then the comment line, I'll just comment everything out for you. And then let's go up here and just comment this out as well to avoid any warnings. And then now that we're over here, so we have our get int, and we're going to be checking 3 and 5. So we're going to be doing it twice here to make sure it's working as expected. So let's put a break here between line 53 and 52. Then let's just comment this out as well. So Control comment button, and it's going to comment it out. So we're going to run these lines to test the code that we just wrote to make sure that it's working as expected. So let's do Control F5. Okay, so it's going to say enter the following 2, 6, and 3. And we can also go over here inside of the labs folder, and we can check correct output to make sure that we get the expected output. So we are going to enter in 2. It should say invalid value. Okay, and then 6, and then 3. Okay, so right now we're missing these little tabs here. So let's go ahead and add that in because we clearly forgot to do that. let's close it. Let's go back into input.cpp and let's check out what we're doing here. So we have user values to get int. So it looks like we just got to add a greater than symbol right here. So it matches the output here. And let's also put a space as well. There we go. So let's do Control F5 again just to run it. And so it's good that we just tested this so we can see that we should get the same output as they're expecting. So first we want to try 2, and then it's going to say invalid 3 and 5, which is what we want here. And then we're going to put 6, and then we're going to put 3. So you entered 3, so that works. So now it wants to test that we're checking for a whole number here. So it's going to say enter an ABC. So let's do that. ABC. So bad integer entry. Please try again. So now we're going to enter in 4, and it should work. Perfect. So now we can ensure that the code we just wrote works as expected and should be error-free. So let's go ahead and now go back to the lab. So now the second method we're going to write is another getInt function, but this is going to receive a reference to an integer and then our 2 other parameters for the upper and lower limits. And then we're going to return a Boolean to see if it's a valid entry or not. So if we look over into the main.cpp, we can see why it's going to ask us to return a Boolean. So let's uncomment this. And here, as you can see, they have a while loop here that's going to keep running until we pass in true. So it's going to say not get value. So if we enter in a valid number, we'll return true and then say not here. So that true will really be a false, and then it'll break the loop. And we're passing in the reference here of num, so that automatically gets updated when we call the function. Now let's go into input.h to write the prototype. So we're going to give it a return type of Boolean or bool, and then we're going to call it getInt, and then we're going to overload it again now, but with 3 parameters. So the first parameter is going to be a reference to the number. So we'll do int reference, and then we'll call it number. And then we'll take in an int min value, and then again an int max value as well. And then end it with a semicolon. So now let's write this inside of our source file. Okay, so this function is going to be a lot simpler. First, we need to get a whole number from the user. And to do that, we can call our first function again, 0 parameters, called getInt. So we can write number is equal to getInt. So this will get us our whole number. And then we're going to return if it's valid or not. So we only want to return true or false if it's in or out of the range that we want. So we can actually simplify this quite a bit and just write return this exact logic right here inside of our return statement, because we return a Boolean in this function call. So let's paste it in, and then let's just update it because we don't have user value here. We have a number that's coming from the parameter. So the reason why we're able to do this is because in the if statement, this is either going to calculate a true or false value. And if it's true, it goes inside of the function. If it's false, it hits the else statement here. So same thing here. If this is true, it'll just return true with the function. And if it's false, it'll just return false for the function. So then later over here inside of our main, when they're calling it here, it'll work perfectly within that while loop because it's going to return true if we got a good value, and it'll break this loop. And it'll break because we have the not symbol. And then if we enter in a bad value, it'll return false. And then it'll keep running because if you do not false, it's really true. And a while loop keeps running while the condition is true, right? Let's go ahead and test this now. I'm actually going to comment out this first part here because we already tested this, and I don't want to have to keep re-entering all of those values again when I'm trying to just do a quick test. So I'm going to do Control / again to comment it out. Save it. Now I'm going to do Control F5 to run it. Okay, so it's running now. So I'm going to enter in all these values to make sure it's working as expected. And before I run it, let's just go over here and let's find the expected output. So the expected output looks like it's right here. Okay, so let's do ABC. Should say bad integer entry. Okay, let's enter in 2. So it should be between 3 and 5. So that doesn't work. Let's try 6. Let's try 4. You entered 4. Okay, perfect. So this works as expected. So I think we should be done with step 1. All of these functions work as expected. And now we're done with function overloading. Okay, so I think we can fully uncomment this now. Let's just clean it up again to its original state. Okay, perfect. So now that we're done with this, I'm just gonna comment it out here, both of these lines. And now we can go ahead and uncomment that reverse function here. So let's just comment out the bottom half, but keep this uncommented. So now we want to write that reverse function. So let's go back into the instructions and let's scroll down to step 2. So step 2, this is where we'll be using dynamic memory to create an array and then store a bunch of values. So here we have a function called reverse, and it receives and returns nothing. So let's go ahead and write the prototype for that actually. I'm just going to copy the name of it. Okay, let's go over to dma.h. Receives an unknown number of double numbers. So it looks like this is the comment for it. So it receives nothing and returns nothing. So that should be the right prototype for it. Let's create it inside of that source file. Okay, let's clean it up a little bit. First thing we're going to want to do is take in a input from the user to see how many values we want to store. So here it says enter the number of double values. Enter in 3, and then we prompt the user for 3 values, and then we are going to display those values in the reverse order. So let's get started by first taking in the user input and prompting the user. So let's start off by writing int size. So we're going to create a size variable here to store the size of the array that we want to create, and this will also be the user's input. So we'll write cout, and we'll write enter the number of double values. So I'm going to copy that and paste it right here, and then I'll put a new line and then the arrow so we can replicate this down here. And then once we do that, we're just going to do cin, and we're going to take in a value for size. If you want to get fancy, you can actually probably use the getInt function here from the input module, but I'm just going to do a cin to keep it simple. So now let's create the dynamic memory to hold all the doubles we want to store now. So to create dynamic memory, we're going to use a pointer. So we want to store doubles. So we're going to create a double pointer, and we'll just call it numbers. And using that size value that we got from the user, we can specify this to be an array of that size. So we'll make numbers equal to new double, and then we'll give it a size of size, which is what the user just entered. So if they enter in 5, this will create an array of doubles that's 5 indexes long. If they enter in like 50, it'll be an array of 50 doubles long. So that's how that works. So that we just created dynamic memory here. So now let's create a loop to take in values for all of our indexes. So let's just replicate the structure that they have here. So we're going to create a for loop. Let's do for int I is equal to 0, and then while I is less than size, and then I plus plus. So here we're just going to see out like the number, an arrow, and a space, and then we'll cin for the user's input. So we're going to do cout, and we're going to cout, and we'll just do I plus 1, because I starts at 0, but here we want to do like 1, 2, 3. Without plus 1, this will say 0, 1, 2. So this just helps with the output to look pretty. And then we're going to do the arrows, and then put an arrow with a space, and then end it there with a semicolon. And now we can do cin, and we'll cin into that index of the array for numbers. So we'll do numbers at index I. So for the first time this runs, we'll cin to numbers at index 0. The second time it runs, we'll cin to index 1, and so on until we hit size. So once we get all of the values for our numbers array, let's just do cin.ignore here, because we don't need any more cins, and we don't know what we'll be calling after this. So after we do that, let's now create a second for loop, and we're going to print out all the values in numbers, but in reverse order of what we entered it in. So to do this, we're going to start at printing the last index up until index 0. So we need to do like a countdown. So we'll do int I, and instead of making I equal to 0, we'll start it off by making I equal to size, which is like what the user entered. And we'll do size minus 1. And then we'll do, well, I is less than or equal to 0. And then we'll do I minus minus. So this will be the countdown for us. So if they enter in, for example, 5, it'll start at index 4 and go 4, 3, 2, 1, 0. And it'll print out all of the indexes in the array. Then all what we need to do is just print it out to the console. So we'll do cout arrows. We'll do numbers at index I, and then end line here. Okay, so that should print it all out in reverse order. There's no special format here. And then at the very end, in the instructions here, it says we need to deallocate the allocated array. So whenever you use the keyword new, you're basically reserving memory inside of your computer to be used in this pointer. So what we want to do is once we're done using it, we want to free up that memory so other parts of the program have access to it and they can use it as well. So to do that, we're just going to use the keyword delete with some square brackets and then the name of the pointer that we allocated that memory to. So we allocated memory to numbers, so we'll write numbers. And this should completely deallocate all of the memory that we allocated in this function here. So now this should work as expected. Let's go inside of the main function now and let's just run it to make sure that we have no errors here. So here it says enter 1, 2, 3, 4, and 5. Let's look at the expected output and just make sure that it's running as expected. Okay, so we want to so once we enter in 1, 2, 3, 4, 5, it should just print them out in reverse order. So 1.1. Oh, I did that wrong. I entered in the wrong value first. I got to enter in 5 first. Okay, so control F5. So now let's enter in 5. So number 1, let's do 1.1, 2.2, 3.3, 4.4, and then 5.5. So now when I press enter, it should print 5, 4, 3, 2, 1 in that order. 5, 4, 3, 2, 1. It looks like this works as expected as well. So now we can carry on to the next part. So I'm going to comment this out as well. And then I'm just going to uncomment this last part here. I'm also going to uncomment this. And I'm going to uncomment this function down here as well. So now we're going to create all of these functions down here. We're going to create get contact, display, set empty, display, and deallocate. So let's go inside of our dma.h. And let's just click over to our lab again to make sure that this is what we're supposed to do. So it says working with compound types. So we want to create a getContact function that basically returns an address of a contact structure. And this is the contact struct that we have. So let's go ahead and just create it right here. So we're going to want to return the address of the contact. So here's a hint. We basically want a contact pointer as our return value. And we'll call it getContact. And let's click into it and create the definition in the source file here. So let's clean it up. The first thing we're going to want to do is create a new contact. We're going to want to create a pointer contact. So let's write contact pointer. Let's just call it C for short, and then equals new contact. And then we're going to want to take in the name, last name, and phone number. So we're going to take in some input from the user here. So let's do that. Let's just do cout, and we're going to cout for name. Let's do cin.getLine, and we're going to get line into C, and then use the arrow notation because it's a pointer. So we need the arrow notation here. And we're going to put this into name, and then we'll write 21 here. So it takes up to 21 characters, because if you go inside of here, we can see that the name's 21 characters long and the last name's 31 characters long. So inside of here, we'll take in 21, and then for last name, we'll do 31. So now let's do last name. Let's just copy this actually. And let's paste it. Now we'll write last name, and then for here, we'll update this to last name, and we'll update this to 31 as well. And then lastly, we just want to take in the phone number. So we'll do cout, and we'll take in phone number, and then semicolon, and then we will cin into our phone number. So we'll do C and then arrow notation, phone number. And then down here, just for good practice, let's do cin.ignore because we're ending off with a cin and we don't know what's going to be called after that. So before we go into our main function to test it, let's just write out all of these functions because they're all pretty small and these actually help us test it. So let's go back into that dma.h and I'm just going to slide this over here. Perfect. Okay, so next let's do the print method here, which displays a contact in a line. So we don't need to return anything here, so we'll just call it void, and we'll call it display, and we'll take in so it's saying it wants a constant reference of the contact being printed. So a constant reference would be const, so that's a constant, and then a reference would be contact ampersand C. So that's a reference to the contact. And now let's just create it inside of our source file here as well. Perfect. And they want us to display it in this format here. So it's just first name, last name, comma, space, plus phone number. So let's just go ahead and do that. So we'll do cout, and we're going to see out the c dot name, and then we're going to put a space between the first name and the last name. And then we're going to do c.m last name. And then we're going to put a comma, a space, and the plus sign, just like how they have it here. And then we'll display the phone number. And then we'll do arrow, and then c dot phone number. And then let's end the line here. Perfect. So this should work how we're expecting it to. Next, let's do the deallocate function. So let's go over here. And the deallocate function is basically going to take in an address of contact. So we can deallocate that address. And it's not going to return anything. So I will do void because it does not return anything. The name of the function, which is deallocate. And then a pointer to contact. So contact pointer C. Let's write it inside of the source file now. There we go. When we deallocate single pointers, it's going to be different than deallocating arrays here. So here, when we create the pointer for this double numbers array, we're saying so numbers is equal to new double and then the square brackets and size. So this is an array. And whenever we have a pointer that's an array, we want to delete it with the square brackets to say, hey, this is an array, delete the pointer that's an array. So that's putting it simple. So now when we want to deallocate our contact, as you can see, we're just doing contact pointer C is equal to a new contact. This is not an array. It's just a single pointer to a contact. No array. It's just a simple address value, basically. So when we have simple pointers like this, just new and then the data type, we deallocate that pointer by just writing delete and then the name of that pointer. So we do not need to put delete square brackets. Again, that's only when we have arrays like how we did up here. So new double and then the size of the array. Here we just did new contact and it's not an array. So because it's not an array, we just do a simple delete and then the name of the contact or the name of the variable that we have, which is C. So good practice is to check if this is not equal to null because you don't really want to delete null pointers. So we're going to say if C is not equal to a null pointer, then we will control X and control V. So if C is not equal to a null pointer, let's delete it. And then after we delete it, it's good practice to make this equal to a null pointer. And then that's all what we need to do for the deallocate function here. We just want to make sure it's not equal to a null pointer, delete it, and just delete it simply because it's just a normal pointer, and then make it equal to a null pointer. And that's all what we need to do for the deallocate function. Now, lastly, let's do the setEmpty function. So all what this does is it basically empties a contact. So it'll set the names to empty C strings and then set the phone number to 0. So if you look at the expected output, I think after they call that setEmpty, it just prints out this. So first name and last name will be null and then 0 because that's what we'll save as the phone number. So let's go over to our dma.h. Let's write the prototype for this function. I don't think we want to return anything, so void. And then we'll call it set empty. And then we want to take in contact reference. So here, reference to a contact. So we'll just use contact and then the ampersand there for a reference. And again, we'll just call this C to put it simple. And now let's click into it and create the function inside of the source file. Okay, so first thing we're going to do is we're going to set the first name and last name to empty C strings. So there are a few different ways you can do this. So I'm just going to do it the way how I like doing it. So all what you need to do is just set the name and the last name to a null character or like the null terminator reference. So to do that, we could just write C dot name, and then at index 0, we'll make it equal to that like null terminator. So it's just \0. So when we try to print it out now, the first index in this array will be this. So it's going to tell the compiler that there's like no text in it. Just end it there. And then we'll also do this for the last name as well. So C dot M last name. And then at index 0, we'll make this equal to that null terminator. And then lastly, we want to set our phone number to 0. So we'll do C dot M phone number. We'll make this equal to 0. So now let's go into our main function here. And let's call test contact to make sure this works as expected. So let's click into our expected output. And we're going to enter in the name, last name, and phone number. And then it should print out this. So let me just increase the size here so we can see it better. So I'm going to press Control F5 to run it. We have an error. What is our error? Okay, what is our error here? We have get contact must return a value. Oh, I completely forgot that we need to return contact here. So at the end of the function here, we're just going to write return C. There we go. So that's what we need to do. Let's stop running it. Okay, let's do Control F5 again. So now we should be free of errors. Now let's run it, and let's just resize this. So here it's going to say, so enter in John Doe and then the phone number here. So this is what we'll be entering in right here. So John will do Jon Doe, and then 4 1 2 3 4 5 1 2 3 4 5 6. Enter, and then it's going to print out John Doe. And it looks like it prints out John Doe, and then the empty name and the empty name. So it looks like it works as expected. Now let's run this in the command line with valgrind to make sure that we have no memory leaks, because we do have some dynamic memory here. We have the contact, and we have this numbers array here. So let's go ahead and do that. For Visual Studio, I'm just going to right-click here, and I'm going to press Open in Terminal. So once this opens up, I'm just going to type in WSL. Perfect. And then I'm going to type in that G++ command to make sure that it runs as expected. And I'm just going to make this a little smaller as well. So I'm going to write G++ dash wall, and then dash std is equal to C++ 11, and then dash G dash O, and then we'll call it WS because that's going to be our workshop or our executable file. And then we're going to write all the names of our .cpp files. So we're going to write dma.cpp, input.cpp, and main.cpp. So let's write that. So dma.cpp, input.cpp, and then main.cpp. So let's press enter and see if we have any errors. Looks like I didn't type the command right. I need to put a space between 11 and G here. Okay, so let's press enter again, and this should work this time. Perfect. So it compiled as expected. So now let's run valgrind and let's make sure there are no errors. But before we do that, let me just double check main to make sure everything's uncommented. It's not. So let's uncomment everything actually first, and then we'll recompile it again. Let's just clean up the code a little bit here to make it nicer. These are missing semicolons. There we go. Okay, so now let's go back into the terminal here and let's recompile it one more time. We should still get no errors. Now let's run valgrind. So VAL grind show error list equals yes, and then leak dash check is equal to full, and then dash dash show leak dash kinds is equal to all, and then dash dash track dash origins is equal to yes, and then we're going to call ./ws because that's what we called our executable file in this command. So when we press enter, it should run the program, and we're going to run the full thing to make sure we get what's expected inside of our output file here. Let's scroll up to the top and let's press enter in here. So here we go. It's going to start running. So first we're going to enter in 2, 6, and 3. So let's do that. 2, 6, 3. You entered in 3. Now we're going to enter in A, B, C, and 4. So A, B, C. Bad integer entry. Please try again. So now we're going to enter in 4. So you entered in 4. Perfect. And now we're going to try to enter in ABC, 2, 6, and 4. So ABC, 2, 6, and 4. So it looks like it's working as expected. And now we're going to enter in 5 and then all the numbers here. So enter the number of double values. So we want 5 double values. We're going to do 1.1, 2.2, 3.3, 4.4, and then 5.5. And then this should print out 54321. 54321, perfect, just like our expected output. And then lastly, we want the first name, last name, and phone number. So let's do John Doe, and then 44, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. When we press enter, it should finish the program and tell us if we have any memory leaks. Now we're going to press enter. So we have no errors, and we allocated 10 blocks and freed up those 10 blocks. All heap blocks were freed, no memory leaks. Perfect. So now we can ensure that we have no memory leaks, and this looks like it's running as expected. So good luck submitting, and leave a comment and a like if you found this useful. Thanks, guys. Bye.